All right, folks. I hope all of you are doing well. And we're just about to start the webinar. Unfortunately, there is some issue with our LinkedIn connection. And there is some issue with our stream going on LinkedIn. So I'm just going to see if we can connect into that and get started there. There's some issue trying to connect into LinkedIn, which is what is causing this particular problem. Just give me a second while I try and fix it, maybe. Just trying to, looks like our connection to LinkedIn has just not worked because StreamYard seems to have some difficulty with LinkedIn. Let me try and see if we can join LinkedIn from somewhere else. Just give me a second while we try and figure this out. Um, just give me a minute. Sorry, folks. Just wanted to make sure that we are just set for the LinkedIn thing to work as well, because a lot of people are joining us on LinkedIn. Unfortunately, it doesn't seem to be working. I'm just going to try and see if it does work on LinkedIn, and we'll see if we can go live on LinkedIn with that. Just give me a second. I'm just trying to figure this out. Fortunately, this is not the most ideal time for this to happen, but hey, we have providers, we have third-party tools, and unfortunately, when these third-party tools don't work, especially when you're about to go live, then we have problems. Let's see if I can set up a parallel stream on LinkedIn from another source and see if I can. Yes, right. I'm just gonna go live here as well. Unfortunately, I'm not sure. All right, I think I'm just going to continue with this. It's not working on LinkedIn. I'm not able to connect StreamYard to LinkedIn, which is why we are having all these problems. But there's nothing much we can do about this. The application just doesn't work with it. It was working just fine. For some reason, it has just stopped working with LinkedIn. I'm just going to try and see if I can do one last thing. If it does not, we'll just move on. I think we have a few folks who've joined us on StreamYard directly. Sorry about the delay, but the idea was that we could do this on LinkedIn and StreamYard and a whole bunch of places. Um, and that unfortunately is not happening. All right. So, with that in mind, I'm just going to I'm just going to go live on a whole bunch of different sources. Uh, just see if that works. All right. Yeah, I think we'll just go. Unfortunately, we're not able to go live on LinkedIn, but we do have to go. We can go live on StreamYard, and I am going live on Twitter. So those of you who are interested in catching this on Twitter, you can just go to my live on Twitter, and you can get this on Twitter as well. Unfortunately, I'm not going to be able to do it on LinkedIn today. Um, I've just set up my team to tell everybody on LinkedIn that they can join in on Twitter. Um, just give me a second. Yeah. All right. So let's get started with today's webinar. Unfortunately, we've had some technical issues with LinkedIn and StreamYard and all of that stuff, but I don't want this to be a showstopper for us. Let's get started. So today's topic is can you delete the I can't delete it. I'm gonna get somebody has posted a message saying, can you delete this? Unfortunately, I'm not gonna be able to delete it. I've told my team to take care of this. We are going to be streaming on StreamYard, of course, as well as on Twitter. Uh, so let's get started with today's topic. Today's topic is essentially doing secure defaults using Semgrep and static analysis. Basically, that is the topic of today. The idea here is that we want to implement secure defaults for our application security, and Semgrep is one of the tools we've chosen for us to do this. But really, it's not only Semgrep. We can do this with static analysis. The idea is that how do we do this with static analysis? How do we scale a secure default program with static analysis? That's basically what I'm going to be talking about in today's session. And throughout the session, I'm going to be taking questions and so on and so forth. And we'll be looking at how to do this and how to do this effectively. As always, in my webinars and sessions, live sessions, I do a lot of demos. So this is no different. I have a lot of demos. I have a few demos planned in this session as well. All right, let's get started. I'm going to start sharing my screen. Just give me a second while I share my screen. And I'm sure most of you are going to be able to see my screen very shortly or have already started to see my screen. All right. So, this the topic today is security defaults and static analysis in Semgrep, right? So the idea here is that we all of us love the idea of secure defaults. Now, secure defaults, we'll explore first of all what it is. But this has been something that I have been a big proponent of. I've always loved to talk about secure defaults. I've always uh, promoted secure defaults within teams that I consult with, even within my own team and so on. Secure defaults is really something that can prevent a whole bunch of application security vulnerabilities and exploits from happening. And by just implementing secure defaults or by just having those in the first place right out of the box, it can be a complete game changer in terms of what it can do for you, right? So secure defaults is a really, really powerful way to solve a lot of major application security issues. So today's topic is essentially going to be about secure defaults and how we're going to scale this, how we're going to run this within and of course, how you're going to look at static analysis to be able to enforce this sort of pattern within your organization, within your team, within your application unit, and so on. Now, first of all, the agenda is going to be what are secure defaults and why? What do they mean in the context of web applications? So, what are they in the first place? What does secure defaults really mean? Implementing and scaling secure defaults. And of course, finally, we'll look at leveraging SAST. I'm going to look at Semgrep as the tool of choice to do this simply because I find Semgrep to be a very powerful tool. At the same time, it's open source. So, you do have the open source benefit for you to be able to do this without you having to spend a whole ton of money on doing this with a commercial, only a commercial option. You do have a whole bunch of open source options. Semgrep happens to be one of them. It does happen to be my favorite option when it comes to doing this, especially for static analysis for secure default. So this is a very important topic that I'm going to be looking into. But we'll start off with the first question: what are secure defaults? Right. So secure defaults, really, put it simply, I really like this definition of secure defaults. That is, products that are resilient against exploitation out of the box. This, I think, would be the simplest way to express secure defaults. So this definition I have borrowed generously from CISA Secure by Design. So the cybersecurity agency in the US has created a secure by design uh, documented framework, and a lot of organizations have signed the Secure by Design pledge. The idea here is that these government agencies are, or at least in this case, the CISA has created a Secure by Design, and one major aspect of Secure by Design is secure by default and secure defaults. And the idea of a secure default is that you have some kind of security features that are implemented in a given platform or product, whatever it is, and it's implemented out of the box, or it's available out of the box, which means that you don't have to necessarily sit and turn on a whole bunch of configurations, or you don't need to necessarily start to implement a whole bunch of things to make them secure, which it's already there. In many ways, it's already secure out of the box. It's resilient against exploitation out of the box. Now, this is classically, I think, captured by this example, and I use this example to demonstrate the power of secure defaults. Now, let me tell you a little bit of a story and go down Python memory lane, right? Now, Python is one of the most popular programming languages. I think now with AI and with all the LLM stuff that's happening, Python is become even more popular. I don't think its popularity is going down. Python has, not had. Python has, there is a very popular library in Python called PyYAML. Now, PyYAML, I don't know how many of you have used it, how many of you continue to use it. PyYAML is a library that allows you to parse and create, serialize and deserialize YAML, right? The YAML, just like JSON, is another serialization format, and PyYAML allows you to serialize and deserialize, create, parse, whatever you want to do, slice and dice YAML. You can do that with PyYAML. Now, PyYAML had a huge security issue in the 3.x version, or just will anything under the 5.x version. And this was crazy stuff, right? Now, what used to happen in PyYAML just under 5.x was that let's say you had a YAML that you wanted to load, and you use PyYAML to load that YAML. So let's say you were getting somebody was uploading a YAML statement or YAML file, or somebody was trying to parse some YAML in their Python application, and they used YAML.load, which is the standard function that you use YAML.load. And there were some malicious parameters or malicious input inside that YAML that would just literally execute the remote code execute on that particular server. Just allow remote code execution. So let's say the YAML had an instruction that says run this, command, use bash and then run this particular command, or do whatever else. It would literally just do that, right? It would deserialize, and it would have all kinds of massive impact. It would be remote code execution. It was simply because it used to parse certain system instructions from YAML, and the library just worked that way, right? That was just the way the library worked. You had another function called safe underscore load, which didn't do that behavior, which was a safe version of that behavior, right? So the default behavior was unsafe, and they had another function called safe load, which didn't do that crazy, find system instructions to just execute. It didn't do that. Now, this was obviously a huge problem, simply because most developers out there, most guides out there, most of the implementation instructions out there would default to people using YAML.load. And this was big. This was a big problem, simply because when people were using that YAML.load, they were vulnerable by default. They just had no choice. They're just vulnerable, right? Now, what they did, very interesting thing that the library maintainers did in version 5.x and above, is that they changed it up. Just one change. They just made the load function the secure by default function, and they created another function called unsafe underscore load. And by doing this, what they did was everybody who was using load is now secure by default. And if you wanted to use the unsafe functionality, let's say you had a genuine need for it, for that functionality, you would have to use a function called unsafe underscore load. And you would clearly know that this is not a good thing that you want to do. You need to be very careful while using it. You probably need to do a whole bunch of things to do it. But the idea was that they made it secure by default because load, the default way of calling it, was secure. And the unsafe underscore load was clearly called out as saying, hey, this is not good, don't use it. But if you really have to use this function, which is unsafe underscore load, you need to know what you're doing. This is your responsibility after this point. This really was a huge change to the entire Python ecosystem. In fact, there were libraries related to DevOps and other, other frameworks that were vulnerable because of this flaw. And overnight, this stopped being an issue because the default functionality became the secure functionality. And this is what I mean. This is a classic example of a secure by default. There are several examples of this. Another classic example of secure default is using it in cryptographic implementations. Right? If you look at a typical cryptographic library or crypto library in most programming languages, it could be Python, it could be Java, it could be Ruby, it could be what have you. You will see that they support a whole bunch of algorithms, whole bunch of hashing functions, whole bunch of key stretching functions, and so on. Now, most of them are not built for security in the sense that a lot of them are outdated functions, or they're using, or they allow you to use insecure crypto function, I mean algorithms. They allow you to use insecure hashes or insecure key stretching functions and so on. The idea is that they put a lot of onus on the developer to know about cryptography, which is really not something a developer would really know. So today you have a lot of secure default libraries like Google Tink or libsodium that do not even allow you to use those insecure crypto implementations, right? Insecure algorithms or insecure functions, whatever it is, they don't even allow you to use it. For example, just these two lines of code in Python gives you an idea what I'm talking about here. The first three lines of code here, you will see 4 or 5 mistakes, which means they're using an insecure mode of encryption. They're padding it. Developers don't know what they're padding it with. They're base64 encoding the ciphertext, and then that is vulnerable to timing attacks. Whereas if you use a secure default library like libsodium, all you have to do is pass the message into the box, the sealed secret box that they have, or secret box implementation that they have. And you don't need to think about padding. You don't need to think about the mode of encryption. You don't need to think about anything. The developer doesn't have to really bother about anything because they're using a secure default, and the library handles all the heavy lifting of figuring out what's the algorithm and stuff like that. It's really not something that the developer is exposed to. The developer does not have any concept of what they need to do. They don't need to think about, oh, what does this cryptographic implementation mean? They don't need to know that. And that's the point. You, as a developer, you should not have to know which cryptographic function to use. You should be able to use this library without the fear of having without the fear of having it blow up in your face. And that's basically what security faults mean. Now, if you look at if you look at vulnerabilities, right, there are multiple ways of handling vulnerabilities. Now, one of the best ways that I think that you should handle vulnerabilities is essentially reducing entire classes of risk, right? Now, SQL, let's say you are an applicant. This is very simple to give you an example of what I mean by this is that let's say you have SQL injection. Now, SQL injection used to be a very serious issue, still is a very serious issue, by the way. But the point is that today it's not so much of an issue simply because most of the libraries and frameworks and so on, or most of the frameworks that you are using, especially the newer ones, they just allow you to use the ORMs or the object to relational mappers that do not require you to even know SQL. And by default, they would parameterize SQL statements. So they've eliminated the entire class of that SQL injection risk in many applications simply because of using certain secure default libraries. So the most effective and scalable way of securing your applications is to scalably reduce these classes of risk. And this can be done with secure default, right? Otherwise, you're always trying to find individual bugs and playing that vulnerability whack-a-mole, and it never works out, right? So this is really one of the benefits of reducing classes of risk. So if you look at the vulnerabilities and threat scenarios by complexity, you'll see that a lot of them can be completely reduced to zero with secure defaults, right? If you look at TLS today has become table stakes. Everyone who puts an application on the internet today can do TLS for free, and that's become a secure default. Because of that, you don't have so many issues that you used to find with applications that were missing TLS and so on and so forth. The same thing with SQL injection. A lot of the frameworks today, you don't have to think about SQL injection at all, simply because you're using an ORM. And unless you are using a vulnerable function within that ORM, or a function that is meant for raw SQL queries and stuff like that, you are really not vulnerable to SQL injection anymore. A lot of the front end frameworks, or even the, especially with front end frameworks, they are not as vulnerable to XSS anymore, because a lot of them have started output escaping by default, doing contextual escaping, and so on. As a result, XSS is not there. A lot of these flaws have been addressed by several frameworks that have made them secure. Right? Secure defaults are something that you see across the board in several frameworks most of the time. So this is something that you want to do. So if you look at CISA's secure by design, they talk about secure defaults in this way, right? So they talk about different approaches to doing secure defaults. Eliminate default passwords. So for instance, set on first use type of passwords for a strong password. So on is an example of secure default. Reduce hardening guide size. This is actually a very interesting point. I don't know how many of you have done server hardening or component hardening. You would have known that. I mean, it still happens. Of course, it's still I think the norm that you'll have these huge hardening lists that you'll have to do. But if your product ships as a relatively secure by default product, you will see that your hardening guide size is very little or smaller, much smaller than what it would have been if all of those configs had to be enabled by an administrator and figured out by an administrator. If they shipped with those configs enabled by default and somebody had to turn them off or use some other method to do it, then that would essentially be a much reduced hardening guide size, because they've already come pre-hardened, and there may be some small configs that you need to do, but by and large, the product comes in pre-hardened, right? Actively discourage the use of unsafe legacy features. This is an example where that cryptographic example comes into the picture, right? Using bad encryption algorithms, using bad hashing functions is unsafe legacy feature. So if you use libraries like Tink or libsodium and so on and so forth, you are essentially eliminating the possibility of unsafe legacy, simply because you don't even have them. They don't even give you the access to use those unsafe legacy algorithms, right? Or implement attention grabbing alerts. So it's not always attention grabbing alerts, but even renaming a function like dangerously set or unsafe underscore load would make your developer's life so much easier, simply because now they know that, okay, I'm doing something that's potentially unsafe, so I shouldn't be doing it. So this is something that grabs their or once they use it, having some kind. I saw this recently in a library that I was creating, where they said that do not use this because this is considered unsafe. Implement this or use this flag instead, something like that. Right? That is an attention grabbing alert. So all of these things are very useful for you to think about secure defaults. And I think this is a great list to just even get started. In fact, CISA Secure by Design is a great read for overall product security and how you can make it secure by design. But just on the secure defaults front, which is something we're talking about today, this is a very great read, and you should think about this list. So, how do you do this? How do you actually implement secure defaults? So, a lot of times it comes down to the framework, right? If you have the choice, if you have the ability to select the framework or to be able to influence the decision of the framework, you should use secure default frameworks. A lot of the newer frameworks in any language, it doesn't have to be only Java or Python or something like that. Any language, if you take frameworks, web frameworks at least, you'll see that a lot of them ship with a lot of these security features, batteries included, right? They just ship them out of the box. So if you can influence them, that is great. This would be the best case scenario, right? This would be secure default frameworks, because these frameworks come with a plethora of features that make it secure by default. They come with these secure defaults. The next best option that you would want to use is obviously use secure default libraries. Now, a lot of times you may use a legacy framework. You may not have the choice to be able to do it. Your application is something that it's been running for ever and ever, and you don't really have the choice of framework. In that case, you might have to start resorting to using secure default libraries. And it's not only the case with legacy applications, but even with secure default frameworks, in some cases, you might have to use secure default libraries because for some things, like for instance, SSRF prevention, or things like cross-site scripting prevention, or things like DDoS prevention, stuff like that, you might have to use secure default libraries. Or for cryptography, you might have to use secure default libraries that would essentially block off an entire class of vulnerabilities from creeping into your application. Right. So this is something that you can do with a lot of this. The other things that you can do, and this is the third best option, right? Now, the third best option is really where you take existing libraries that you know have these potential issues where that could have a vulnerability or that could have a vulnerable state, and you patch them or you wrap a secure implementation on top of them and have your developers use that secure implementation rather than the original library itself. Right? This is a wrapper library. So very simple example of a wrapper library is that a lot of times we use in especially with JavaScript applications, we use a lot of regular expressions, right? Now, one of the things you can do is that with regular expressions, if you don't add a timeout, if you have an abusive an abusive user who feeds in a huge input, it might trigger a regular expression denial of service attack, and that might cause a denial of service condition for your application. But by using a wrapper library that essentially adds a timeout to every single regex call that's happening, that would completely eliminate the possibility of regular expression denial of service or DDoS against that application. So a wrapper library might be something that you can use. So you have multiple choices. And the good thing today, and I'm saying this as a practitioner of application security for several years. I've been in the application security space for 15 years. And I can say safely that it's a great time to be building secure applications today because you have these things available to you. There was a time when this was not available to us, and today it is available. You do have frameworks that are secure by default. You have libraries that enforce secure defaults. It's a great time. Although even with this, I still see some really egregious mistakes that a lot of companies make and teams make. But nevertheless, today is really a good time to be doing this in a very significant way. So this is something. But more than all this, the last point is something that we want to do, right? All of these things are important. The first 3 points, absolutely important. You have to do all three things. You might have to do a combination of all of these three things. But the last point is critical because if you can't do the last point, the first 3 points kind of become pointless, right? You really can't do anything with the first 3 points because developers may still resort to using insecure libraries. They may resort to using bad patterns within the existing frameworks. They may not use that wrapper library. They may not follow any of the things that you've or the paved road you've created. So you would have created this wonderful highway for your developers, or your engineering team has defined this wonderful highway, but you might have that one developer who's unaware, or one team that is not, that's not willing to do this, that might just go off on a rogue path and cause all kinds of problems. So you have to enforce these patterns on developers, and that's really what we're here to talk about, which is how do we enforce this. And this is something that we can do with, of course, static analysis. And more than just static analysis, you can do this with good static analysis, right? So now let's talk about what good static analysis is. Now, first of all, I'm sure some of you who are watching this know the difference, or at least know bad static analysis, right? Now, bad static analysis has shown up often, right? Especially with a lot of tools or the ways the certain tools work. Bad static analysis is all around us. It's not new to see bad static analysis. What is bad static analysis? Now, bad static analysis, in my view, is something that is, first of all, bad. The rules are too generic, or the rules are too broad scoped. They're very extensive in terms of the rules. You have a lot of scenarios where the rules are some things you can't tune, you don't have the customization options. They find a whole bunch of noise that has generated a lot of false positives that are created. It's not very high fidelity. You don't have the ability to do a lot more focused implementation. A lot of them are only language focused. They're not framework focused. They're not platform focused, depending on how you're using the static analysis or which static analysis tool you're using. So a lot of times you're dealing with crappy static analysis tools. And the idea here is to use something that is high fidelity, but not just high fidelity. It's not just the tool. That's what I want to say. Right? It's that in this case, you should understand that the tool, yes, while it does play a role, an extremely important part of success with static analysis is the way your applications are developed for security itself. So let's say you decide to choose a path of secure defaults, you started using certain secure default frameworks and libraries. Static analysis becomes a much easier job to use for enforcing good patterns rather than static analysis in an environment where you're just trying to find as many vulnerabilities as possible, and you're constantly playing catch up with those vulnerabilities. That's always happening with a lot of teams. So a lot of static analysis basically looks like this, right? Needle in a haystack type stuff, where you're looking for that bad pattern, or you're looking for those set of bad patterns, and you have thousands and thousands of rules, hundreds of thousands of rules, and you're trying to find those bad patterns in your typical SAST structure. And a lot of us have automated it. A lot of us have put it into our CI/CD pipelines, but we still find a whole bunch of false positives. I recently just spoke to a customer of mine where they are triaging 1,200 or so static analysis findings, and they're like, we're just drowning in static analysis findings. We're just not able to get a hold of this, right? And a lot of it has to do with the way we build our apps or the way we enforce secure defaults. Secure defaults, in my opinion and in my experience, can bring down the load of static analysis quite a bit and help you focus on very specific things in static analysis. So how do you do static analysis and leverage that with secure defaults? So enforce the use of secure defaults. So let's say you have defined, let's say you're a Python house and you're building a bunch of Python applications, or you're building Python web applications. Is there, if you're using, let's say, a Django framework, you've started off on a good front, you're started off on a good note simply because you're already using Django. You're not really the framework comes with a whole bunch of security capabilities and security features. It comes with it out of the box. You don't need to enable them. You don't need to explicitly enable them for them to work. So if you can do that, you have automatically started using those frameworks or those libraries. So let's say maybe libraries in your case, you've started having developers use this, or you're enforcing or just essentially having your developers use these secure default libraries. So let's say you've started down that road already. Now, what you want to do at this particular point in time is set up your static analysis findings or static analysis rules to look for violations of those secure default patterns. So you have certain secure defaults, but obviously they can be turned off. They can be, they can be set to, you may be using a pattern that is violating them in some way that says, what, override the security feature and still do this or something like that, right? You may have default violations. You're basically looking for violations. You have this picture of known good, which is your secure defaults, and you want to ensure that that known good is not, you're not straying away from that known good, or not straying away from it in a way that might cause all kinds of issues, right? You're not straying away from it unless you have a very strong justification to stray away from it. So the idea here is that you're already starting to use secure default. It could be a library, it could be a wrapper, it could be a framework, it could be what have you. And the idea is that you've set up static analysis to look for violations um, of those secure default patterns. And if you find violations in your build or your PR or whatever it is, you're able to tag them back, and you're getting the developers. You're essentially enforcing the use of secure defaults because you are looking for violations of secure defaults rather than looking for all possible vulnerabilities in your applications. You are looking for violations of secure defaults. Now, this is a journey. It's not obviously going to happen on day one. It's for some teams, it's going to take some more time. Some teams, it's going to take less time, depending on your platform, your framework, your application, your language. All of that stuff makes a difference. The way you approach this makes a big difference. But the idea is this is what you should work towards. The best teams in the world have approached it this way, right? They've been able to start implementing or enforcing these secure defaults because they're looking for violations in these secure defaults. Only if there are violations of these secure defaults, which is much easier to find, even in static rules as well as in actual in reality, it becomes much easier to find. And once you do, you just get them to fix it, and that cycle continues and continues and continues so on. Right. So this is really what we want to do with secure defaults. Right. So just to give you real world examples before jumping into my demo, this is an example. These are some example of secure defaults, and we're going to use Semgrep to figure this out. So the first example of a secure default is Django, right? Django is a very popular web framework in Python, and by default, Django ships with an ORM. That is, you're never exposed to writing raw SQL queries. It just ships with an ORM. You can just use object queries, and you'll be able to start querying the database and so on. Now, you do have a function called extra. So that is, an object dot extra, and you can pass a raw query into object dot extra. And then if you have a raw query with a where clause, you still have SQL injection. But that is a violation of the security default. Only a use of an extra function with a hard-coded where clause parameter can result in SQL injection. So the idea here is that you are still looking for SQL injection, but you're not scanning 10,000 different SQL injection rules. You are looking for a violation of security default because you are using Django. You already know that Django has ORMs which are protected against SQL injection. And because you have Django and they're protected against SQL injection, you have the ability to look for a specific violation of that pattern. Very similar to this is Ruby on Rails, where you can create a model, and in that model, you can declare the model by default doesn't allow you to do mass assignment, which means you can't set all possible parameters and have force the backend system to accept those parameters, and that causes an authorization bypass. It causes mass assignment. This was the vulnerability that led to GitHub being compromised in 2013. Not compromised. It was a bug bounty style finding in 2013, where somebody was able to tamper with a parameter called isAdmin, and they became the GitHub administrator because they were able to tamper with that parameter. And because Ruby on Rails by default was vulnerable to mass assignment, today Ruby on Rails is not vulnerable because by default they have made sure that people can only access certain attributes when they are setting serializing or deserializing data. Right? So that's something you have. So the violation of this secure default would be if this functionality is turned off, or if this flag is turned off. Right? So that would be a violation of secure default. Java Spring Boot ships with CSRF protection, right? But if it's turned off, developers can turn it off. If it's turned off, then that is a violation of security default. So the idea here is that you're not looking for every possible scenario, you're looking for secure default violations. And let's get to our example here. And we're going to be using Semgrep. So I just set up a lab on AppSecEngineer. This is not a lab that's available for others on AppSecEngineer. We might choose to introduce this at a later time, but the idea here is that you have a lot of these labs on AppSecEngineer, so please feel free to check it out at any given point in time. So what I'm going to do is I'm going to start the lab on AppSecEngineer just to show you how this works. And one thing you will see, if any one of you are AppSecEngineer users, you will see a very new thing that we are going to introduce very soon, which I'm going to be showing you for the first time. So I don't know how many of you have worked on AppSecEngineer labs here. I don't know how many of you are logged into the stream right now. But if you have worked on AppSecEngineer labs, you would have noticed, an IDE or a developer environment open when the lab starts up. Right now, we have replaced that with a full VS Code. So you actually get a full Visual Studio Code experience on the AppSecEngineer lab, and that's really powerful. So now you have a lot more syntax highlighting, you have a lot more ease of use. You have browser proxying. You have all of that stuff. You have it's really cool what you can do with the new lab IDE with AppSecEngineer. So just waiting for it to spin up, and then I can show you the demo that we're going to look at very shortly. So almost done. Here we go. So now I'm just going to move the instructions over to another screen. Just give me a second. Yeah, so you'll actually see a full-fledged Visual Studio Code, and you can actually interact with it as a full Visual Studio Code application. So you'll see that we have our lab set up with some rules and so on. Now let's actually open up our rules and look for what we're going to do. So let's start off with our Django example first, right? Now we have so this is a Django application, and we are doing a whole bunch of things here. And you'll see that in most cases, we are doing some we're using some bad patterns. You might, in this case, we're using a bad pattern here, but the real thing that we're looking for by default is this, right? So this is what we are going to do. This is what we're going to do, which is looking for this extra function here. So the idea here is that if you're using the extra function in the Django application, you're you're potentially passing dynamically constructed SQL query. You're using a raw SQL query. That's basically what's happening here. And we want to find this raw SQL query. So we've basically written a Semgrep rule that looks for this extra pattern. This is a simplistic view of the Semgrep rule that we're looking at. You can have a whole bunch of things that you can do. So what we're looking for, this is what Semgrep is really great at, in terms of what it can do, simply because you can use a combination of patterns. You can use a pattern either. You can do things like uh, use this pattern. It could be this pattern or this pattern or this pattern. It could be inside a function. It could be outside a function. You can even set up things like meta variables in SemGraph and so on, which makes the identification of these vulnerabilities much easier, right? So understanding the SemGraph syntax is very useful, because once you do this, you're able to do quite a lot of stuff. You can hone in on very specific patterns. You can keep, in some cases, you can have a good mix between breadth and depth in terms of the pattern. So in this case, we're looking for a pattern called use of extra, which is anything that uses the extra function. So any model that uses the extra function is going to be considered vulnerable, and it's not one of this. So basically we are saying that it's not inside this. If you're using it like this, the pattern not inside is what we're looking for. We're looking for this pattern and the pattern not inside, in this particular case, inside this function like this. So this is probably the correct pattern. This is okay, it's not a problematic one. But if we just do an extra like this, we have a problem. So that is something that we are looking to find. So let's actually open up our terminal and run this rule. Oh, I need to allow it. Okay. So when I run this against my Django code base, you will see that it immediately. Oh, I'm sorry. I need to go to a particular directory. My mistake. And if I run this, you'll see that it should show me the violation of this. It says, hey, this is what you're doing. Query set.extra does not provide safeguards against SQL injection, so on, blah, blah, blah. Instead of using extra, use the ORM, so on. So use the ORM directly, don't use extra. That's basically what we're saying. And you'll see that it was able to find this particular issue as a problem. So we have a very clear finding, and we're able to do a secure default violation. We are not trying to find 300 different patterns of Python SQL injection. We are just trying to find, we are very clearly a Django web application. We are using Django to build our application. We just want to find this one pattern that would be, if somebody is using the extra function for using database queries, that is a no. You can automatically block that. You can catch this in your either as part of the build process or in your PR, and that have this fixed. So it's much faster to identify. First of all, you can have fewer rules, you can have more high fidelity rules, and you're looking for very specific things, and that makes a huge difference when you're dealing with applications that are also equally huge, right? So that is something that you want to do. Now let's look at another example of this, which is our Ruby mass assignment one. Now, this is actually a very interesting example. Now, you'll see that, so this is an example of the user uh, model. So we have a user model, which is called user. And the idea here is that when a user is created, you can take any parameters of the user model and set it. So the user is just, it's literally that if the attacker can guess that the user has a parameter called isAdmin, and they can change that to true false during the creation process, there is no protection for mass assignment. So you'll see that the protection capability, which is enabled by default, has been turned off. So because it's been turned off, we want to be able to find the violation of the security default. So the security default is that this is enabled by default, but because we're using without protection true, and you'll see this is a nice thing about Ruby, right? Or with a lot of these security defaults, they've clearly said without protection. They've called out to the developer that, hey, you're using something without protection. So now we are going to try and find this with a rule with Semgrep. So let's look at the Semgrep rule, which is actually not that complicated at all. So here you'll see that we have a pattern, model.new, params, whatever other variables can be passed, or whatever other arguments can be passed into it. And you say without protection true, and that could have other arguments after that. So this is a pattern to find models that have been instantiated without protection set to true. And this is a very important thing. By just catching this violation of security default, you have a very easy way of identifying mass assignment, which is a huge authorization issue, by the way. So this can have a pretty huge impact on your authorization and, of course, your application itself. So let's identify this. Let's run this. This would be, again, and finding this, and it says, yes, hey, here you go. This is the line. It has without protection set to true. And you're able to identify this without protection set to true. That is what we have as far as this is concerned. So you can very clearly see that instead use attribute accessible for the model to disable mass assignment using this sort of thing. So this is a very powerful way of identifying. Very similar to this, right? So Java, if you look at the Java example that I'm going to show you soon, that also has a very similar thing. It essentially says object CSRF dot disable. If you've called the CSRF object, you've called CSRF module, and within that you've set it to CSRF disabled, then you have a policy violation. And if you look at our Java CSRF example, you'll see that this is a route that is doing something, and you'll see CSRF disabled, and this is a problem. So this is fine. This route is fine. It has CSRF enabled by default, which is what Java Spring is supposed to do. But now, if you run this with, again, Semgrep, so if you look at the Semgrep rule, you'll see that CSRF disable is set. And now if I run the rule, you will see that it finds the CSRF disabled parameter or the CSRF disabled route setup. So it only finds one thing, because by default, the pattern is already set. We don't need to worry about that pattern. By default, the pattern is secure. But because somebody has violated that secure default pattern, we're able to find it. And you have tons and tons of these sort of things that you can do. And the benefit of, and you can very clearly see the benefit of secure defaults, I'm sure, by now, where you can, first of all, it becomes easier to get your developers to do the right things, and it's very little cognitive load in most cases for them to do the right things, because the library itself handles the security default. That's what it's there for, or the library or the framework itself handles it. So it ends up being a much smaller fix rather than having to deal with this huge fix for developers. So the cognitive load, the overall effort for the developer is lower. Second thing is, you are using a trust but verify approach, right? Because as a as a developer, yes, they may be using a security default library, but there may be new developers, there may be developers who just joined the team who don't know about it. There may be people who just use insecure patterns anyway, and you should still be able to catch it. And this helps you do that in a very comprehensive way. And so this is something that you can do. And this is something that you can generate right from your threat model, right? So you can essentially use this to say that, okay, these are the secure defaults that we have, but there may be violations in this way. So we want to be able to create rules, and you can create Semgrep rules or whatever other tool that you're using for static analysis. Semgrep is only an example of that. You can load these rules and make them much more, first of all, uh, low false positive or almost no false positive. And you can also ensure that they are easy to identify, easy to fix, easy to explain to the developer, because they've already been trained or made aware of the secure default pattern. Right? So that is something that you should consider doing with secure defaults static analysis. All right, I think I've come to the end of what I had to say, and the webinar for today. Now, those of you who joined in, thank you so much. I'm sorry about the initial technical glitches. It was not our fault. StreamYard suddenly decided to not work with LinkedIn, and so I think there's some bug there. But nevertheless, I really thank all of you for joining in. Those of you joining in, we have some very interesting news coming to AppSec next week. We are launching our first ever new certification, and I'm really looking forward to seeing many of you take that up. And if you are there at Black Hat or DEF CON this year, do look us up. We're at both these events, and we look forward to seeing all of you there in these events. We're training at a bunch of trainings at Black Hat. Of course, we are training at DEF CON as well. So this is the first time for us training at DEF CON. We've spoken, we've done workshops at DEF CON. It's the first time we're doing DEF CON as well. So really looking forward to it. Thank you for joining in for this webinar. Appreciate your time, and have a good rest of your day, wherever you are. Thanks.